Coming on to the next question, in which we will basically discuss about schema integration, handling redundant data, etc., and resolving conflicting values. So first we start with schema integration. It's basically merging different database structures, that is like joining tables, etc. Uh, it gives a unified schema where all data flows with the same structure. In this we need to map and standardize the attributes. Data types may differ, like one has a number, one has string values, etc. Then we have handling redundant data. It basically means we handle the duplicate records or duplicate data by removing them or minimizing them. Example, same student feedback data might be filled again and again by the same student, and same faculty entry collected from different departments, etc. The ways to handle it are basically using identifying duplicate values, removing those records, and updating the table regularly by keeping only the most recent or the complete entries. Then the next topic we have to talk about is resolving conflict in values. It occurs when the data item has different values. For example, same student gives different ratings in two surveys. The ways to resolve it are basically using average or the most recent or the most frequent value, give priority to trusted data sources, apply business rules. The latest entry is valid, which we talked about earlier, that is using only the latest data which has complete entries. Then it would result in consistent and reliable integrated data if we use these ways to resolve the conflicts in values. Then we moving on to the next question. uh, we have to discuss the normalizing methods. So first comes min-max normalization. So first of all, what is normalization? It scales data into smaller values, like large infinite values, into very small values like between 0 and 1. So min-max normalization, the formula is simple. The data value minus the minimum value divided by the difference of max and maximum and minimum value. Its disadvantages are it's sensitive to outlier, but it's simple and easy to understand, and it maintains original data relationships. Z-score normalization, we have talked about it earlier as well. So the formula is basically removing mean from the data value and dividing it by the standard deviation. It is still affected by extreme outliers, but the major advantages are it reduces effect of different scales. Like still extreme outliers are there, but uh, the average outliers are handled easily by this method, uh, and it's very useful when the data follows normal distribution. Z-score, then comes Z-score normalization using mean absolute deviation. In this, instead of dividing it by standard deviation, we divided it by MAD, that is mean absolute deviation. Its advantages: it's less sensitive to outliers, more robust than standard z-score, but it's less commonly used. Then we have decimal scaling. We move decimal point of values by 10, 100, etc. That is, for example, say 725. If we take 3 up to 3 decimal scaling, it will be 0.725. It's less precise for complex data sets, but it is a very simple method, and there is no need for using min or max values over here. Then coming on to the next question, which is we are given a data set over here, and we have to calculate uh, the normalized values using these four methods that we talked about earlier. So first is min max normalization. As we all know the formula, we would just apply it. For example, the first data is data point is 200. So 200 minus the minimum value, which is also 200, divided by the maximum difference of maximum and minus minimum, that is 1000 minus 200, 800. It would be same for every data point, and the minimum value will be also same for every data point. Just the data point value at each row will be changed accordingly. So we will get normalized values like these. For z-score, we will first calculate the mean and the standard deviation. So the as we all know, the formula for mean, it's basically the average. Standard deviation, we also know, square root of whole summation of x minus the x mean whole square. Similarly, we will calculate z-score normalized values, and instead of using standard deviation, we will use absolute deviation. Then calculate the uh, mean of the absolute deviation, and then divide it with the mean absolute deviation which we calculated before. These and this is how we will get the normalized values using z-score normalization using mean absolute deviation. Decimal scaling as used earlier. If we take up to 3 decimal places, it will be 0.2, 0.3, 1. These will be the normalized values. Coming on to the next question, which is question number 15. In this also we have to do the same. Now coming on to the question number 15. In this also we have to do and apply the same normalization techniques to the feedback data set that we used earlier. So we know the minimum and the maximum value, and we can calculate it as it is for every range. For z-score normalization, still we know the formula. It's what we discussed previously, the square root of x1 minus x bar whole square in summation of all the data points, and the square root of that. Then we have decimal scaling, which we already used over here. That is for taking say 35. So for 2 decimal places it would be 0.35. The most appropriate method would be z-score normalization, because it shows how far 35 is from the average feedback level.